today I'm here to make a presentation on agrodrone, which is going to help farmers to make their productivity and yield better. And I'm going to take help from the IoT and its applications. Like basically, agrodrone is an application of IoT which helps the farmer to increase their productivity and yield. So basically, IoT is all set to push the future of farming to the next level. Smart agriculture is already becoming more commonplace among farmers, and high-tech farming is quickly becoming the standard thanks to agricultural drones and sensors. Basically, the farming industry will become more important than ever before in the next few decades, and the world will need more than 70% of the food than what is required now. So basically, we need to take help from IoT to increase the productivity in the later decades. And drones are one of the applications that we can use in the future. Like drones have become an invaluable tool for farmers to survey their lands and generate crop data. And as a concrete example, we can take example of John Deere, one of the biggest names in farming equipment, and has begun connecting his tractors to the internet and has created a method to display data about the farmer's crop yields. All of these techniques help make us precision agriculture the process of using technology to observe and record data with the goal of improving production while minimizing cost and preserving resources. Drones aren't a new technology by any means. My idea is to design a drone for farmers that is multi-beneficial for them, so that it helps the farmers in spraying pesticides in a particular region where there's a need. Then also add some features such that it makes noise to minimize the grazing when the farmer is not in the farm. The extra features that can be added to the drones are it can be used to analyze the quality of the soil and check the humidity using sensors. Drones can have hyperspectral, multispectral and thermal sensors to identify which part of field is dry or needs improvement. And basically the idea that I'm going to use is like soil and field analysis. Drones can produce precise 3D maps for soil analysis useful in planning seed planting methods. Secondly, for planting, drones can be used for planting too, as in drone will shoot pods with seeds and plant nutrients into the soil, providing the plants all nutrients necessary to sustain life. Thirdly, drones can be used for crop spraying. Drones can scan the ground using ultrasonic echoing and lasers and spray the correct amount of liquid. Result is increased efficiency, and farmers will not have to suffer from diseases that are caused by pesticides. And further, drones can be used for nowadays the people who work with pesticides and insecticides are at a greater risk if they are not properly dressed or if they have a broken or leaking equipment. Hence, my approach is to try to develop a prototype model of autonomous agrodrone to facilitate the farmers, wherein a click of a button would spray the pesticides and the farmers wouldn't have to sit in their farm in the scorching heat, protecting their crops from the animals, as the drone will have a property to make noise and shoo them up. Basically, my model of a drone is it needs a tilt motor mechanism which enables to perform the conventional takeoff and VTOL. VTOL is basically the vertical takeoff and landing. By this feature, the agrodrone is empowered to operate in congested farm fields and remote areas where conventional takeoff can't take place. And the autonomous control fitted to the model facilitates autopiloting, pathfinding, path calculation, area and distance calculation. And the pressurized tank system provided at the undercarriage initiates the spraying of pesticides through the nozzle provided. Thus, the complete automation of the agrodrone helps the farmer to carry out pesticides, spraying and virtual crop monitoring in real time, reducing time, effort and cost. Agrodrone is operated by using a battery. First, the current from the battery flows through the motor using ESC. ESC is basically the electronic speed controllers. Then the motor drives the propellers to provide the required forward thrust. The fuselage carries the pesticide tank, compressor and sprinkler to spray the pesticide by drawing the power from the same battery. The quad configuration helps greater stability than both the bi and tri-rotor configurations to achieve tilt rotor mechanism. Increasing the number of rotors directly increases the stability of the aircraft. However, the quad configuration gives the desired stability and performance for the required weight considerations. The fuselage is the main body that will hold the pesticides and insecticides and sprayed with the help of nozzle. And the pros and cons of my agrodrone is it can be used for soil, and like the pros basically are it can be used for soil and field analysis. It can also be used to develop time series animations to show precise crop development, which reveals production inefficiency, hence better crop management. And it can also be drones are also easier and cheaper to deploy. Drones equipped with hyperspectral thermal sensors can identify the parts of the fields that have become dry and spray minimum amount of pesticides required for the betterment of the crop. And the cons of using agrodrone are most of the drones have short flight time and flight range, and therefore it can't fly for like a longer duration or the range that a farmer wants to. Drones with the features that qualify them for use in the agricultural field are also quite costly. Most of the drones are weather dependent, like if it's rainy, windy or cloudy, it's very difficult to fly them, and hence it depends on the weather. The images that a drone captures can be understood by a skilled and knowledgeable person. This means average farmer without these skills needs to be trained first, and which requires Then the future enhancement in the field of drones are it can be fitted with artificial intelligence, so that if the machine encounters an unforeseen circumstance, it can take decisions on its own just like the human brain. Or the drones can be fitted with experience-based artificial intelligence, and experience-based artificial intelligence are self-improving systems that make tentative, additive, reversible, very fine-grained modifications without prior self-reasoning. Thank you.